problems are actually a little deeper, and that means we actually have to read and think, and there's all these words to look up. And there's just work involved in physics, and we have to do it. So let's suck it up and get going. So we got a rugby player running with the ball directly towards his opponent goal in the positive direction of the x-axis, just like this. And if we skip just a little bit ahead, we're told that this is moving at 4 meters per second. Now what happens is that this player throws the ball at 6 meters per second. And we want to know the smallest angle that it can have for the pass to be legal. So we want to find this angle theta right here. Now here's the deal. I've got me running, so I'll just say v of the player is going to be 4, 0. And once again, we're using that convention we use in class with north, east, south, and west. And east is positive x. And then we have the velocity of the throw, which apparently we know that the magnitude of the velocity of the throw, what we can say is this, and I'm going to write this a little bit fancy. I can say Vx of the throw, Vy of the throw, if we use Pythagoras' theorem, those components work out to it having a speed of 6. Okay, so in other words, the throw here is, you know what, I could actually go over here and show it. So the throw here is, if I just take this guy, I'm going to actually take this guy, I'm going to paste it here and just kind of show you what my thinking is. So if I take this, oops, sorry, take this, I split it into components, I have an x component and I have a y component, like this. And so what we're basically saying is that this x component has to cancel this one here. I mean, it has to have a speed of -4. So let's be clear on this. I know I'm kind of just solving the problem and jumping in here, so you're expected when you watch these videos to like read the problem before you watch the solution and try to figure out what it means for yourself before you jump in and do this. So if you're like a little bewildered right now, stop the video, read the problem, back it up, start over again. Okay. So continuing on, we don't know what this Vy is, so let's just kind of figure out what we can say here. I can say that Vx is -4, Vy is unknown, so I can say, using Pythagoras' theorem, that Vx squared, this is the trick, plus Vy squared equals 6 squared. So that's going to be Vx squared, that's 16 because it's 4 squared, so 16 squared, plus Vy squared equals 36. So 16 plus, sorry, that's 4 squared, which is 16. And then Vy is going to be 20. So if I wanted to get the angle, I could do the inverse tangent of 20 over 4, or -4, whichever one you want to do. And so theta is going to be the inverse tangent of 5. I'm going to plug that into my calculator, and I'll get my answer. And so I actually end up getting 78.7 degrees. Now here's the weird thing about this. What I've kind of realized is this going this way, it's actually the largest angle we can get. So I'm forced to draw this weird conclusion. It must mean that the angle they actually want us to measure is this angle right here, because if you go smaller than this angle, the throw starts to become illegal. So the only thing I can think is we're going to have to take 90 minus 78.7 to get the angle that they actually want, and that actually works out to 11.3 degrees. So I'm showing you kind of how I check my work. So that's something that you kind of, sorry about the little trick there, but it's a good thing for you to see. Okay? And we have videos, so you can kind of watch this a couple times and get a feel for it. Now, for question number 73, we have 2 ships leaving the port at the same time. So we've got ship A going northwest. And when we say northwest, we mean exactly between north and west. So that's an angle of 45 degrees if we're going like that. And this is ship A, and it's going 24 knots. And then this second ship is going this way, 40 degrees west of south, so this is 40 degrees, and it goes 28 knots, so that's good. Now, we want to know the magnitude and direction of, so knots a mile per hour. So we want to know the magnitude and the direction of the velocity of ship A relative to ship B. And then we want to know what time will ships be 160 nautical miles apart. So we've actually got quite a bit to do on these problems, and what I've kind of realized is this is way harder than anything that you're going to see on your exam. So what I might do is I'm going to offer this one as a challenge problem, and like I'll work it out, but I just don't want to do it on a video right now because it's something that I will definitely stumble on. But if you can actually get this one, I'll give you a free quiz grade for it. Seriously, if you can actually solve this problem and get it right with no help from me, and no help from Mr. Musalam or any other teacher, but you can actually get it by yourself, I'll give you a quiz grade. I'll give you a free quiz for it. So there's that. Now, let's see. Next problem. We have a light plane. It has an airspeed of 500 kilometers per hour, and we want to go. So this is what the plane does. So it goes 500 kilometers per hour due north. So this is like what the plane actually does. But it has to head 20 degrees east due of north to do that. So what's happening here is it's actually going 20 degrees like this. So it goes 500 kilometers per hour like this. So there's this crazy wind that blows it like that. And so here's the first thing, is we don't actually go 500 kilometers per hour. It looks like the plane arrives in 2 hours. So if we go due north, we actually end up going 800 kilometers in 2 hours. So this ends up being a component of 400 kilometers per hour. So what I'm kind of realizing is this is another super hard question. So if you can get this one, I will also give you a free. I'll work these out, but I will also give you a free quiz grade on this one as well. So if you do this, what I'll do is I'll take one of your quizzes, and what will happen is if you can do this problem and hand it in while other people are doing a quiz, we'll give you some kind of a bonus, like you can use that time to do something else or figure out something. But I want it to be a thing that if you can get this, you get some kind of reward for getting it that involves you getting out of a quiz, because this is a great problem if you can get it. Okay, so now here we go. 75 is much more reasonable. We have flakes falling at 8 meters per second, but then we have this driver going at 50 kilometers per hour, so let's convert that to meters per second. So 50 kilometers per hour times 1,000 meters over 3,600 seconds to do that conversion. So we'll do that conversion and we'll get our number, which is 13.9 meters per second. And now we can actually get the speed of the snowflakes and the angle they form. So I will actually have this be your Google Doc question number 1 for this second video lecture. Excellent. Very good. So you will solve this for me. So you get the angle. And actually, I also want to know the speed. The driver says, actually, no, don't worry about that. So just get the angle. There we go. Now, let's see. So I'm kind of realizing that these are quite tricky questions for us to do. So I'm going to come up with some more questions that are actually a little bit easier. So this is some great stuff to kind of finish up on. And when I see you guys in class next time, what we're going to do is we're going to play some Video Jeopardy. We'll play some Jeopardy or Someone Who Wants to Be a Millionaire. Go over some problems and get you guys ready for next week's stuff when we actually start projectile motion in earnest.